In this lesson, we'll examine a very useful strategy to consider when answering quantitative comparison questions. The technique is to perform the same operations on both quantities. In particular, you can add any value to both quantities, subtract any value from both quantities, multiply both quantities by a positive value, and divide both quantities by a positive value. Now, this is a very common technique that can be applied to a wide range of questions. So let's look at some examples. In this question, notice that both quantities share some identical terms. They both share a positive y term, and they both share a negative 3x squared term. We can eliminate those terms by performing the same operations on both quantities. To begin, let's add 3x squared to both quantities. When we add 3x squared to quantity A, it cancels out the negative 3x squared term, and it cancels out the negative 3x squared term in quantity B as well. From here, if we subtract y from both quantities, we're left with negative 7 in quantity A, and we're left with 6 in quantity B. At this point, when we compare negative 7 and 6, we see that 6 is greater, which means the correct answer is B. Now, I should point out that if any of the algebra here confuses you, do not worry. We'll cover all of the necessary algebraic concepts in a future module. At the moment, just familiarize yourself with the technique of performing the same operation on both quantities. Alright, let's try another one. Now, you may wish to pause the video and try this one before continuing. Okay, in this question, it would be much easier to compare the quantities if the variables were on one side and the non-variables were on the other side. To accomplish this, let's first subtract w from both quantities to get the following. Next, we'll subtract 4 from both quantities to get this. At this point, the variable is on one side and the constant term is on the other side. From here, we can simplify matters even further by dividing both quantities by 6 to get the following. At this point, it's very easy to compare the two quantities. Since the given information tells us that w is greater than 0, we know that w is positive. As such, w must be greater than negative 1, which means the correct answer here is A. As you can see, we were able to solve this question by performing a combination of these acceptable operations on both quantities. Now, when it comes to acceptable operations, you may be wondering why we can't divide or multiply both quantities by a negative value. To answer this question, let's examine a very rudimentary question. Now, of course, it's obvious here that quantity B is greater than quantity A. However, notice what happens when we perform any of the acceptable operations on each quantity. For example, if we add 8 to both quantities, we get these results. And as you can see, quantity B is still greater than quantity A. From here, if we subtract 4 from both quantities, the new values are such that quantity B is still greater than quantity A. If we divide both quantities by positive 3, we get these results, and it's still the case that quantity B is greater than quantity A. If we multiply both quantities by a positive 6, the resulting values are such that quantity B is still greater. However, notice what happens if we take our current quantities and divide both of them by a negative value. When we divide both quantities by negative 2, we get negative 6 and negative 9. And now it's the case that quantity A is greater than quantity B. This, of course, is a problem. Our original goal was to compare these two quantities, and when we performed any of these acceptable operations on the quantities, the resulting values were consistent with the conclusion that quantity B is greater than quantity A. However, when we divided both quantities by a negative value, quantity B was no longer greater than quantity A. This problem will occur whenever we divide or multiply both quantities by a negative value. So when it comes to performing operations on both quantities, we must ensure that we only multiply or divide the quantities by positive values. This is a very important rule that often comes into play when we have questions like this involving variables. Since both quantities feature the variable x, it may be tempting to divide both sides by x to get the following, and then conclude that since quantity B is greater than quantity A, the correct answer is B. This, however, is incorrect. The problem here is that when we divide both quantities by x, we cannot be certain that we're dividing by a positive value. If it turns out that we're dividing both sides by a negative value, the results will not be consistent with the original comparison. For this reason, we must not multiply or divide quantities by a variable unless we're absolutely certain that the variable has a positive value only. To demonstrate this, let's look at some possible values of x. For example, what does our comparison look like if x equals positive 4? Well, in this case, quantity A equals 8 and quantity B equals 12, which means quantity B is greater. Now consider what happens if x equals negative 1. In this case, quantity A equals negative 2 and quantity B equals negative 3, which means quantity A is greater. So in one case, quantity B is greater, and in the other case, quantity A is greater. As such, the correct answer here is D. The relationship cannot be determined. Alright, so if we're not allowed to divide both quantities by x here, how can we solve this question? Well, the quickest way is to subtract 2x from both quantities, and when we do so, we get the following. At this point, we're comparing x with 0. Well, since x could be less than 0, or greater than 0, or even equal to 0, the answer here must be D. Alright, let's summarize. In this lesson, we learned that we can simplify quantitative comparison questions by performing the same operations on both quantities. We also learned that we must not multiply or divide the quantities by a variable unless we're absolutely certain that the variable has a positive value only.